Hi friends, very good morning. Welcome to Anu Academy. Very good morning, friends. Let us start today's class. Friends, today we are going to discuss fluid mechanics and hydraulic machines. Okay, fluid mechanics and hydraulic machines. So today's class, I have prepared material. So today's class we will be covering capillary rise. Our material will be consisting manometer, differential manometer, types of fluids, steady flow, unsteady flow, uniform flow. Okay, so let us start today's class. Okay, so we will start now. Okay, so friends, I want to share you one thing. Each and every class I am saying the same thing. Give importance for both the papers, as exam date has came for assistant engineering conducted by Andhra Pradesh Public Service Commission. Okay, so let us start today's class. Right. Okay. Four curves are shown in figure with velocity gradient dou u by dou y along x-axis and viscous shear tau along y-axis. So you will be getting a diagram like this. So based on this diagram, what are the members have been pasted in this diagram? You will be getting a question regarding what is the relation of this curve with this velocity gradient and shear stress. Okay, so like that you should be in such a stage that to identify these terms within a fraction of seconds. Okay, see, one more point, one more time I want to remind you, negative mark is there for your assistant engineering examination. So keep this point in your mind and start your preparation. Okay, now, right? So okay, so four curves are shown in figure with velocity gradient dou u by dou y along x-axis and viscous shear tau along y-axis. So the question here is, see, this is A, B, C, D with respect to this velocity gradient and shear stress. So the question here is, curve A responds to ideal solid. Okay, this curve A responds to ideal solids, whereas curve B responds to non-Newtonian fluid. You can see this is the fall of the slope. For B responds to non-Newtonian fluid. C is Newtonian fluid. Okay, C means Newtonian fluid. It obeys the Newton's law, so it is called as Newtonian fluid. D is ideal fluid. Okay, D is ideal fluid. Like that, prepare for your examination. Okay, and next, for a soap bubble, the surface tension sigma and difference of pressure delta P are related as delta P is equal to 8 sigma by D. And next, for a liquid jet, the surface tension sigma and difference of pressure delta P are related as delta P is equal to 2 sigma by D. The capillary rise or fall of a liquid is given by H is equal to 4 sigma cos theta by rho GD. Okay. Manometer is a device used for measuring pressure at a point in a fluid. Differential manometers are used for measuring difference of pressure between 2 points. Definitely you will get this type of questions. The pressure at a height z in a static compressible fluid undergoing isothermal compression is given by P is equal to P naught E to the power minus GT by RT, where P naught is pressure at ground level, R is gas constant, T is absolute pressure. Next, the pressure at a height Z in a static compressible fluid undergoing adiabatic compression. Okay, so previous case it is isothermal compression and here it is adiabatic compression. Okay, now see, whatever the question you are going to attempt in your examination, read the question properly. Once you read the question properly, many times we can observe based on our previous exams what we wrote, and based on the previous experience what we gained from our examinations which we have attempted Okay, so once read the question carefully, because many of experts say that most of the cases 90% answer is in the question itself. So our duty is, we have to understand the question properly. Until and unless if we don't understand the question properly, we cannot go for the correct answer. Okay, so always read the question. If you are not understanding the question, read it twice and read it thrice, so that once you understand the question, it will be easy for you for selecting the proper and correct option within seconds of time. Okay now, right? So here, the pressure at a height z in a static compressible fluid undergoing adiabatic compression is given by P is equal to P naught 1 minus gamma minus 1 by gamma into Gz by R T naught whole to the power gamma by gamma minus 1. Okay now, remember formulas also. Definitely you may get you may get some questions related to formulas also. So it's better what you understand, what you read the topics, related topics. Okay, it's better you write a short notes, so that notes will be definitely helpful for your exam preparation. Okay, right. Now next we'll proceed. The temperature at a height z in a static compressible fluid undergoing adiabatic compression is given as, so previous case we have discussed about the previous, it is for the pressure, and now here it is related to the temperature. The temperature at a height z in a static compressible fluid undergoing adiabatic compression is given as T is equal to T naught into 1 minus gamma minus 1 by gamma into G Z by R T naught. Okay, right. Temperature lapse rate is given by L is equal to minus G by R into gamma minus 1 by gamma. When the fluid is at rest, the shear stress is 0. The depth of center of pressure of an inclined immersed surface from free surface of liquid is equal to Ig sin square theta by A h bar plus h bar. Okay, so we will proceed now. Okay, right. For a submerged body, if the center of buoyancy is above the center of gravity, the equilibrium is called stable. For a submerged body, if the center of buoyancy is below the center of gravity, the equilibrium is called unstable. So you have to identify the difference based on the question, whether it is stable or unstable. Okay, right. For a submerged body, if the center of buoyancy coincides with the center of gravity, the equilibrium is called neutral. Okay, right. Next, the meta-center height GM experimentally is given as GM is equal to small wx by capital W tan theta, where small w is movable weight, capital W is weight of floating body including small w, that is including movable weight, and theta is angle of tilt. Theta is angle of tilt. Next, the time period of oscillation of a floating body is given by T equal to 2 pi into root k square by gm into g, where k is radius of gyration, gm is metacentric height, t is time period. Okay, okay, right. Now we'll proceed. Steady flow is velocity, pressure, density do not change at a point with respect to time, is called as steady flow. Unsteady flow means velocity, pressure, density change at a point with respect to time. Uniform flow means if the velocity in a fluid flow does not change with respect to length of direction of flow, is called as uniform flow. So there is a slight difference between this steady flow, unsteady flow and uniform flow. So these topics, these subtopics covers the basics of fluid mechanics and hydraulic machines. Okay, so it's always better complete be perfect with the basics. Definitely you may score good marks in your examination. Now we'll continue the same part. The depth, see here, the depth of center of pressure of a vertical immersed surface from free surface of liquid is equal to Ig by h bar plus h bar. The center of pressure for a plane vertical surface lies at a depth of 2/3 the height of the immersed surface. Okay. Next, the inlet length of a venturi is less than the outlet length. Next, flow of a fluid in a pipe takes place from higher energy to lower energy. The point through which the buoyant force is acting is called center of buoyancy. Okay, na? Center of buoyancy means the point through which the buoyant force is acting is called center of buoyancy. The point through which the weight is acting is called center of gravity. Okay, na? So this is the difference between center of buoyancy and center of gravity. The point about which a floating body starts oscillating when the body is tilted is called metacenter. Okay, na? So you should be familiar with the meaning of center of buoyancy, center of gravity, and metacenter. Next, the metacenter height gm is given by gm is equal to I by v minus bg. Okay, for a floating body, if the metacenter is above the center of gravity, the equilibrium is called stable. Okay, now next, for a floating body, if the metacenter is below the center of gravity, the equilibrium is called unstable. Okay. Next, for a floating body, if the metacenter coincides with the center of gravity, the equilibrium is called neutral. Okay. So that's all, friends, for today's class. I think all of you understood today's class, and this material will be definitely helpful for your assistant engineering examination. Okay, so if you are having any doubts, you can post in the comments box. I will give you a reply. Okay, if you have not subscribed our channel, please subscribe our channel. We need your support. Please subscribe our channel. Please like and share our channel. Okay, please discuss with your friends regarding the class work going on in our channel. Okay, so prepare well for the exam. Okay, don't miss this opportunity. So please support our channel, and we will be preparing lot of material. It will be definitely helpful for your exam preparation. Thank you very much. Thank you for watching.